it's a light course. We don't have much problems to solve in this course apart from one or two topics. Uh, and we will be discussing more theory thing here related to security, how security protocols are used, where it is used, what are the applications of it. Those things we will be discussing, and keeping the three major security aspects. We will discuss this. Those three major security aspects are confidentiality, authentication, and integrity. So in today's class, we will try to understand what are these three, how it is different, and what are the technologies involved to secure. I mean, uh, to achieve these three aspects of security for any kind of communication. That's what we'll be discussing today. So let us start. So the unit one of information security is the authentication chapter. That is eighth chapter in your textbook. So I am referring Dr. T.R. Padmanabhan and Harini and Harini are the authors, and the textbook name is Cryptography and Security. The from eighth chapter your portions starts. So eighth chapter is authentication. Here in our syllabus we consider it as unit 1. So it will discuss here about digital signatures. What are the authentication schemes, digital signature in authentication? What are the standards of digital signature? What are the protocols for authentication? Like we use Kerberos and directory services. What are these? Where do we use it? What is the purpose of using it? Those things we will be discussing today. Okay. So yeah. What is this signature called basically? You are seeing a signature, right? Where you can write with your hand or with a stylus on a screen, basically. What do you call that signature as? Is it an electronic signature or a digital signature? Because many of us have this confusion. What is the difference between electronic signature and digital signature? So when you have a screen, you have a stylus or your fingers with that. If you sign, what do you call it as? Can anyone tell me?
Electronic signatures.
Yes, you are right. So basically, they are electronic signatures. Don't have a confusion at all. Okay, electronic signatures are where you will not include the keys or any kind of uh, what I can say, uh, any kind of authentication mechanism or nothing is done basically. Okay, just a second. Yeah, sorry. Yes, electronic signature does not incorporate any coding or standards. Okay, you can make a note of it if you want. Electronic signatures doesn't incorporate any kind of coding or standards, whereas digital signatures comes with encryption standards. Okay, keep this in mind. Digital signatures comes with encryption standards. That means we will include, we will try to encrypt the data, do something with that, or hashing the data, do something with that. So that's what we do in digital signature. So most of the times we end up doing electronic signatures. Okay, when we try to sign your reports online, all those are electronic signatures. They are not digital signatures. Please know the difference. They are not same. Okay. So what is the signature called? This way, which is shown in the diagram, it is electronic signature, not digital signature. So basically, these two are like misunderstood, but so how do you define electronic signatures? So electronic sound, symbol, or process attached to are logically associated with a contract or other record and executed or adopted by a person with the interest to sign the record. It's basically electronic signatures. We are not worried about this definition, students. It is some according to a US Federal e-sign Act. Okay, but don't worry about the definition. You can write in your own words if you get a question like what are electronic signatures. Okay, equivalent to your handwritten signature basically. Instead of handwritten, it's not a hard copy of the paper. It's basically you do it on a screen or on a document with the help of a stylus or with the help of mouse or any other external device. So let us see what are digital signatures. Information security starts from here. Yes, whatever the topics we discuss, we will be discussing, that starts from digital signature. Okay. So what are digital signatures? Digital signatures are like electronic fingerprints. Okay, electronic fingerprint. In terms of coded message, the digital signature securely associates a signer with a document in a recorded transaction. Digital signatures use a standard accepted format called public key infrastructure (PKI). We will be discussing about PKI in detail later. Okay. So to provide the highest level of security and universal acceptance. Is that clear? So there are specific signature technology implementation of electronic signature. So there is a link attached with this. If you click on the anyway, I will be sharing the presentation with you later. Yeah. So you can go through key infrastructure. So, but I will be discussing that right now. You need not worry about this. So, what are digital signatures? That's what we were discussing. We will study digital signature in detail, maybe after 1 or 2 classes. As of now, what you have to understand is digital signatures and electronic signatures are totally different. Electronic signatures, we know how to do it, but how digital signatures work, with what keys we are using it, whether it can be cracked by any other person, we are going to see that after 1 or 2 classes. Okay. Uh, Security attacks and services, yes. After digital signature, we will get into the security attacks and services. So basically, in the context of communication across a network, the following attacks can be identified as uh, the first one. So the disclosure and traffic analysis is considered to be message confidentiality. So I will not go through this slide for this topic alone. I will tell you there are three broad categories. Okay, student: authentication, confidentiality, and integrity. So I will like ask you questions now. Where let us see how you know about this, whether you know about this or not. What is authentication? Can anyone tell me what is authentication? What is the necessary of authentication? Anyone?
Sir, it's basically a proof that a certain person or certain organization is only accessing it. It's something like when we try to log into Facebook, it basically we are authenticated to log in. Our username and password is basically the authenticating mechanism, something like that.
Yes. So basically, authentication is proving an identity. Is that clear? Authentication is proving an identity. So generally, when you log into your Gmail or any other kind of servers, the servers authenticates you whether it is the right person who is accessing that particular server or not. Why it has to authenticate? For security reasons. So basically, authentication is the first major aspect of security which you have to keep in mind. Is that clear? So authentication, that is about authentication. Now, what do you mean by confidentiality? Can anyone tell me what is confidentiality? Hello?
Sir, it is about whether the particular message is accessible only to uh, only to a set of people whom it should be. And even if any other person tries to see the message, it should not be an open message. It should be encrypted with some. It should be encrypted.
Yes. So basically, confidentiality means whatever the data that you transfer in the in a medium, that data should be secure. That means when it is in the medium, transmission medium, if anybody looks into the data, the person who is trying to steal the data looks into the data should not understand what it is. Is that clear? That's the basic thing. So how a person will not understand it? When that person cannot understand, how will the receiver understand it? This comes into picture. These questions comes into picture. Okay. The first thing is you have some data. Okay. So you will do some modifications for that data. Say for example, very simple thing I'll tell you. You have say hi, how are you is the information what you want to send. So what you will do, you will convert that into a separate format. How do you convert? Say instead of after every alphabet you will add a number. Is that clear? In some way, say multiples of 2, multiples of 4, something like that, you will keep on adding h 2 I 4 will become high. Okay, how are you? In that case, h 6 o 8 w 10, like that you will do something, you will do some modifications for the data and you will transmit it in the medium. So in the medium, what happens? The person who is trying to look into the data, he cannot understand what it is exactly. Okay. So now when it reaches to the destination, what happens? You will inform the destination, the receiver, that this is how you have made the changes for the data, so that the receiver will only can understand it. Is that clear? Receiver will just remove those numbers, and once the numbers are removed, it is in a proper format, and receiver will can understand the data. This is a very simple example I am telling you. This may not be the right way it works, but it's the analogy I'm telling you. Okay. So for this, you need some kind of protocols like encryption protocols, decryption. Encryption means what? You have a text, you encrypt it. That means you make some modifications to it and you send it to the destination. And in the destination, the receiver has to decrypt it. Only then the actual data will be seen by the receiver. Is that clear? For that, I told you, right, in normal, in the example which I have given you, you have to call and inform that person about how you have made the changes. That is the key. Is that clear? That is the key for the receiver to decrypt it. Am I clear? So the key is associated with encryption algorithms. When you encrypt it, use a key, and using that key, when you encrypt it, the data will be changed. And even in between the transmission medium, if somebody looks into the data is not be visible. Is that clear? That is how you make sure about the confidentiality. And there are a lot of protocol, lot of different types of keys also. Public key encryption, session key encryption, symmetric key, asymmetric keys. We will look into that in detail later. Okay. So that is about confidentiality. What do you mean by integrity?
So basically ensuring that the message has not been changed. There's no modifications to the message that is being sent.
Yes, you are right. So basically, you transfer some data from your system to other system, and in the medium, even if somebody looks into the data, I am not worried about it. I always feel that particular data is not a critical information, or it is not a private information. Okay, but the data what you send should reach the destination as it is. If I send ABCD, receiver should ABCD only. If the receiver receives ACBD, it is wrong. The integrity of the data is lost there. Is that clear? There are chances where the attackers may affect the integrity of the data. Is that clear? Because they may take the data, make some changes to alter the data and send it to the receiver. That cases are there. Is that clear? So integrity is also very important, where integrity stands for whatever the data that you send, receiver will receive the exact data, and we are not worried about the confidentiality there. Is that clear? So keep this in mind, keep these three things in mind. Authentication, confidentiality, and integrity are the three major aspects of security. All these three has to be maintained and managed properly. Is that clear? So under message in confidentiality, basically disclosure. I mean, if the data is disclosed, the confidentiality is lost. What is authentication? Content. What is integrity? If the content is modified, the sequence is modified, timing is modified. All these are message integrity is you can say compromised. And what is authentication masquerade? China repudiates US blame on COVID-19 pandemics spread all over the world. So you can understand from that what do you mean by authentication, confidentiality, and integrity. Is that clear? Source repudiation, that means somebody is doing something but somebody is claiming it, or say for example A is sending a data to B but C is claiming that C has sent the data to B, or A informs that A has not sent the data to B. All are with respect to all are the issues with respect to authentication. They are called repudiation. Is that clear? Source repudiation, destination repudiation. uh, uh, so basically what you have to understand is confidentiality, authentication, and integrity are the three major things which you have to keep in mind, and the whole syllabus of information security stands on these three aspects. Exactly. If you take a mail architecture, how mail will provide authentication, how mail will provide confidentiality, how mail will think about integrity of the data. So in that is about mail. If you are doing an electronic transaction, how all these three aspects of the security are managed. So that is what we are going to study in this course. Is it clear, students, about these three things? Hello?
Yes, sir.
Okay. 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 So with this knowledge, we'll go ahead. So if you have any questions, you ask and get it clarified now itself. Okay. Hope these three aspects of the network is clear to you. So
So can it on repudiates, like it means rejection. So I didn't get the point when you while you were mentioning. Was I audible, sir? Hello.
hello, hello. Am I audible?
Yes, sir.
Okay. Yeah. You asked something. I think there was some network glitch. Tell me.
Yes, I was asking about source repudiation and this one, destination repudiation. Uh,
Okay.
so this
See,
means like rejection.
repudiation means basically denial of the truth. Okay. Say for example, source send a data to the destination and source claims that it has not sent that. But source only has sent that. That's what I told you. A, say for example, A is transferring some data to B. A has to authenticate with B, right? Or if B is sending data to A, B has to authenticate with A. Okay. But generally that won't happen. There will be some mismatch. We will see some examples. When we go through this chapter, we will see some examples. So that is
Okay, sir.
basically scope repudiation and destination repudiation. That means it is denial of truth. You send, but you claim that you have not sent. Or somebody sends and you claim you have sent. It's how it works. We will see some example, real time examples through this chapter. Okay. We'll understand that time. What I'm telling is it is basically associated with authentication. Repudiation is a problem associated with authentication. Okay. That's what you have to understand here. Am I clear?
Yes, sir. Thank you, sir.
Okay. So that's why we need digital signatures. Okay. Digital signatures means when you send a data, for that data, you need digital signatures, not the other kind of signatures what I told you. Okay. Not the electronic signature. We need digital signatures. requires a combination of the use of digital signature and a protocol designed to counter this attack. Is that clear? That means you are sending a data, you digitally sign it and send it so that for the receiver, it is very much understood that you only have sent the data to avoid the problems of source repudiation and destination repudiation. Is that clear? So with this knowledge, yeah, what is message authentication? So under integrity, the same thing what I told you, Alice and Bob example. So interfaces, there is an intermediate uh, we can say a hacker or someone here interfaces with the transmission, modifies the message or inserts a new one. Is that clear? And Bob receives it. How can Bob be sure that M really comes from Alice? Is that clear? Bob should have a confirmation that M has really come from Alice. Is that clear? But what's happening here? Somebody is actually changing the data. When the data is changed or modified, obviously it is not the actual data what you're supposed to get. Even though you're getting it from Alice, but it is not the actual data what you're supposed to get. Basically, integrity is compromised here. So let us see how to handle this. Okay, some terminologies and prerequisites to understand the next upcoming topics. So what is the mechanism or service used to verify integrity of a message? So basically message authentication. Okay, so assures that data received are exactly sent by and that is supposed to identify of the sender is valid. Say for example, you are logging into your mail ID, you have your username and password, you will type your username and password, you can log in. Okay, contain no modification, insertion, deletion or reply. Okay, so a procedure to verify that received messages from alleged sources and not been altered. Also verifies sequencing and timeline. Okay, so basically, I told you already authentication. Don't worry about the second point. What are digital signatures? Authentication technique that also include measures to counter repudiation by the source. That is digital signature. Now, going into this, I want to discuss one more topic. Okay, there are two approaches for authentication, students. Okay, there are two approaches for authentication. Let me see. Just a second. Okay. Okay. It is not added it in the. Okay. Yeah, there are two approaches for authentication, students. One is password-based authentication. Other one is cryptography-based authentication. Okay. So, what do you mean by password-based authentication, and how many types of passwords are there? Can anyone guess? You already know it. Can anyone tell me? What is password-based authentication? There are two types of passwords. One is fixed password and other one is one-time password. Okay. So what do you mean by fixed password? Where do you use it generally? Which we are using in our daily life? You have to just think and let me know. Where do we use fixed passwords?
So for login, like for website purpose, like for the EMS itself, we will be using a fixed password. And for OTP, that's for adding more security, sir. That will be varying every time. We can add a OTP additionally to the fixed password, like how it happens when we register for vaccines or whatever like it
Yes.
happens.
Generally like bank transactions. To log into
Yeah.
your bank account, you need your fixed password, but once you log in to transfer an amount, you need an OTP. Right. So that's how. Now you're right. Okay. Now, what are the problems with fixed passwords? Why? It's a general known fact, right? OTP is better than fixed passwords. Why? What is the problem with fixed password? What happens generally with a fixed? I'll tell you what happens. if you want to log into your Gmail server, what you will do, you will enter your username and password. What happens after that? Once you enter your username and password and submit, it goes to the it goes to your mail server. It verifies in the backend whether that particular username is associated with the same password or not. If that account is available there, it will have some other information also to verify. It verifies, and the major thing it verifies is the password, and if the password is right, it will allow you to log in. So this is how the fixed password works. Now, what is the issue with this tool? Just analyze what might be the issue.
So the password needs to be sent to the server, like from our end to the server end. There's the password will have to travel through an insecure medium.
Yes, that is one problem. Then anyway, that is there in OTP also, right?
Yes, sir. But if the fixed password, like there is something called as computational security. Like after a certain amount of time, it becomes very easy to uh, decrypt whatever is there and identify what the password is. But in OTP, every time it's a new one, so that computational security factor is reduced properly.
Fine, I agree. Then any other issues with the fixed password?
So the fixed password should be uh, stored in a hashed way, and it should not be stored directly in the server. So otherwise the server administrator could know your password if it is stored as a plain text or something like that.
Yes. So basically, the major problem is the password is stored somewhere. Either it is encrypted or not encrypted. See, one more terminology I want to tell you: plain text and cipher text. What is plain text? If you store some data as it is, you are not making any changes to the data. You store some data as it is. It is called as plain text. And if that plain text is encrypted using an encryption algorithm and key, it is called as cipher text because it is encrypted and it is a encrypted data. It is called as cipher text. Just keep these two names in mind: plain text and cipher text. Now, if the password is placed in a in the receivers or in the website somewhere in the servers, so basically if you place it either plain text or cipher text, it's a problem because you are storing it somewhere. Whereas OTP, it is not the case. It is not stored for a very long time. Very minimum amount of time it will be stored, and later it will be erased. Okay. So whereas in the fixed passwords, what happens, you store it somewhere. Okay, when you store it, first of all, that itself is a big problem, whether you have uh, stored it as it is, I mean as a plain text, or as a cipher text. So if you have stored it as a plain text, it is more vulnerable to attacks. More vulnerable to what kind of attacks? Like eavesdropping, sniffing, password guessing, unauthorized access to password file. These are the problems with that. You can make a note of it. Like eavesdropping. Eavesdropping means what? It's a kind of attack where a middleman sits between you and server and tries to listen to your data, which is being transmitted. Okay, that is called as eavesdropping. Sniffing means what? The data that you transfer from your source to destination will be sniffed in between. Okay, password guessing, you already know. And unauthorized access to password file, somebody access to the password file in the server, hacks it and gains your passwords. All these are the attacks. These are all the attacks which can be made to fixed passwords. That's why these fixed passwords are vulnerable. Is that clear? But there is some way you can protect it to a little extent. Okay, to some certain extent you can protect it by storing the password in cipher text. Okay, so there are two ways: fixed password hashing and fixed password salting. Please make a note of it, it is not there in the slides. There are two ways where you can protect your fixed passwords. That is the fixed password hashing, first one, and second one is fixed password salting. Please make a note of it, students. Okay, so what is fixed password hashing? It is a method which stores the hash of the password, which will be known only to the verifier. Is that clear? Or it will be in the verifier sites only. So fixed password hashing means the hash value of that password is only stored, which will known only to the verifier. That means only to the server it will be known. Is that clear? The other one is fixed password salting. What do you mean by fixed password salting? That's a method which creates a random string. Is that clear? Called as salt. That particular random string is called salt. So how that string is created? So basically that string is created. See, when you fill up a form, when you try to create a new account in Gmail, you have to fill up a form, right? You will give all the details like your first name, last name, many other details you will take. Any one field is taken from that form, and that will be concatenated with the actual password. Is that clear? That string is called as a salt, which is being taken, random string. Okay, that is concatenated with the actual password before computing the hash. Is that clear, student? So in fixed password hashing, what happens? The password is hashed and stored. In fixed password salting, for that password, you are adding a string called salt, and both put together, you are hashing it. Is that clear? And that is stored in the verifier. Is that clear? So fixed password hashing and fixed password salting. These two are the mechanisms to at least secure these fixed passwords to an extent. Is that clear? So to avoid what kind of attacks? To avoid uh, unauthorized access to the password file. Anyway, eavesdropping you can't help, because when you are sending itself, your application should have a provision to encrypt and send it. Is that clear? If that option is there, obviously your passwords, what you transmit, is protected from eavesdropping and sniffing. So that's about fixed passwords. Next comes the better one, is one-time password. So basically, like I don't have to tell how one-time password works. So a one-time password is generated at that particular moment, and that will stay as long as 30 seconds, 45 seconds, 1 minute, to a maximum of 2 seconds in some cases. Is that clear? After that, that password is nowhere stored. Even if it will be stored in the verifier site only for that particular minute to verify whether you are giving the same password or not. After that, it is not stored anywhere. Okay, so one-time password is quite secure, and it comes to your personal device. It is that one-time password is sent to your personal device. That is another type of authentication, because your personal device will be handled by only you. So that's what the assumption. Okay, so that's these are the two different approaches of password-based authentication. Is it clear, students? So basically, the other category of approach is cryptography-based authentication. Under password-based authentication, two things. One is fixed password and one-time password. Under fixed password, there are a lot of issues. To at least handle those issues, we have fixed password salting and fixed password hashing. So is it clear, students? Shall we go to the next topic?
Yes, sir.
Okay, the next is cryptography based authentication. Okay, now this is password based authentication. Next is, that is approach 2. Approach 1 is password based authentication. Approach 2 is cryptography based authentication. So this is more effective compared to password based authentication. We will see.
Sir,
Yeah,
slides are not changing for us. We are still in some terminologies and prerequisites.
I have not changed the slides. That's what I told you. Before I continue slide, I wanted to tell you this. Okay, that's why I told you to note down also.
Okay.
Okay, first approach is password based authentication. Second approach is cryptography based authentication. And in password, we have seen fixed password, one-time password. And under fixed password, two approaches: fixed password hashing, fixed password salting. That's all. Next is cryptography based authentication. So, like anything do you know about cryptography based authentication, students? What do you mean by that?
Sir, there are basically two keys in cryptography based authentication. One is public key and the other one is secret key. Secret key ensures that no one can manipulate the data without knowing the secret key. That is, only the sender will be knowing his secret key, and the public key will be everyone who is in the receiving side will be knowing the public key of the sender. So every sender will have two keys, public key and secret key. He will be generating the data, a special key message authentication code using his secret key. Then he will attach that message authentication code with along with the message, and he will be sending it to the receiver, and the receiver will decrypt the message using the public key, and he will ensure whether the public key and the secret key matches, and if that matches, the receiver can be sure that the integrity of the message is maintained.
Okay. Okay. Yes. Before going into it, let me tell you, there are two set of key students. One is symmetric key and other one is asymmetric keys. Okay. Symmetric keys means for encryption and decryption, you will use the same key. You will have only one key. For encryption, sender uses the same key. For decryption, again, receiver uses the same key. Whereas in asymmetric keys, for encryption and decryption, you will use two different keys. Okay. For encrypting, you will use a separate key, and for decrypting, you will use a separate key. So in asymmetric keys, what happens? There will be a pair of key called public and private keys. As your friend said, private key is called as a secret key basically. Public key is something which is known to everyone. Anybody can know anyone's public key. Is that clear? But private key is totally different. If you encrypt something from a private key, say for example, I want to send some information to you. I will encrypt my data from my private key. It is very much sure for you that I am only sending it to you. Why? Because I alone have my public key, private key. No one else will have my private key. Is that clear? But you have my public key. You can use public key to decrypt whatever I have sent. Okay. But if I encrypt something with my public key and gives it to you in an asymmetric key encryption, generally what happens? You cannot decrypt it because you don't have private key. The other key pair you don't have. Private key is known only to me. Is that, are you understanding, students? So public and private keys, what happens if I encrypt something with my private key? Anybody can decrypt and see, but it ensures that I have only sent it because I only have my private key, and since I have encrypted my data with private key, it is very sure that I have sent it. Basically, you're proving authentication there. Is that clear? But if anybody can use, say for example, I can use your public key and encrypt. Okay, it's fine. I can do it. But where it is used, how it is used, we will see to that. Is that clear? So I think since I don't have the slide for this, let me put it in a slide in the next class and continue with the cryptography based authentication. Okay. So before that, before going to cryptography based, now we saw password based authentication. We'll go to cryptography based authentication in the next class. Before that, just make a note of this, students. Authentication is done using three factors. Just make a note. Authentication is done using three factors. Okay. So what are those three factors? What you know, what you have, and what you are. Any of you can combine any two factors or three factors, or you can use only one factor here. So what you know, generally what you know is an authentication factor where answer for this is passwords, passphrases. I know a password, I know a passphrase, so I can log in. Is that clear? That comes under what you know. The next thing is what you have for authentication. I have some a public key, private key, or I have some certificate, digitally signed certificate. These things I have for authentication. That is kind of comes under a factor what you have. The last thing is what you are. Generally we use our fingerprint, we use our retina scan, All these are comes under another type of authentication, which comes under the factor what you are. So there are three factors in which you can authenticate: what you know, what you have, and what you are. What you know passwords, passphrases. What you have, I have certificate, I have keys. What you are, you can take my fingerprint, you can take my retina scan. That is what am I? Is that clear? So these are the three factors of authentication. So you can design your application based on multi-factor authentication or single factor authentication. Multi-factor authentication in the sense you are authenticating with multiple factors, like what you know, what you have. If you are using with single factor authentication, it is like only with what you know or what you have. What say, for example, I'll tell you. Uh, uh, in some companies, what happens? If an employee would like to access the computer, that employee who generally uses that computer, okay, there it's a multi-factor authentication to reach that particular system, okay, where to get into the premises you have to give your fingerprint so that the door will open, or you have to scan your ID card so that the door will open. Is that clear? That is one factor of authentication where you are allowed to get into the job space, I mean the workspace. Then once you are in the workspace, you have to give the password for your computer. That is what you know. And the other one is what you have. Is that clear? Or what you are. So it is multi-factor authentication. Is that clear? So authentication can be done in multiple factors, using multiple factors. So I hope this is clear to you students till here. So we will stop here. We have discussed something about authentication today, and the first approach, that is password based authentication. In the next class, I will be discussing about cryptography based authentication. So if you have any questions, you can ask, or we will wind up today's class. Any question? Okay then. So we will stop here.